A journey that took 35 years and covered a distance of more than 11 billion miles or more than 18 billion kilometers, a human-made object crossed into what is known as interstellar space. This is the spacecraft, the first interstellar space we made it. The object was the Voyager 1, one of the inventions that NASA is most proud of. Interstellar space is special in astronomy. It is the environment between stars. It is a region where solar winds, the stream of highly charged particles flowing out of the outer layers of the Sun's atmosphere, no longer have a significant impact on the cosmos. The region where this happens is known as the heliopause. This is the very region where the Sun's wind collides with the winds from other stars, in other words, the cold, vast regions where the influence of other stars is felt. The only other human-made object to cross this boundary is the, you guessed right, Voyager 2, but this happened a whole 6 years later. To achieve this feat, Voyager 1 had been traveling at a mind-bending speed of 37,000 miles per hour or 325 million miles per year. To understand where Voyager 1 is presently, here is a succinct description of the far, far away region. Imagine the heliosphere as a bubble shaped like a bullet surrounding the Sun. The Sun blasts off solar winds from its surface at about 1.79 million miles per hour. These hot, highly charged particles escape into space, filling up the void with ionized gas. This is known as helioplasma. These solar winds, however, eventually slow down and will come to a halt when they encounter interstellar space where they find denser, cooler plasma from particles formed when stars exploded some 15 million years ago. The heliopause is practically the boundary of our solar system. When the Voyagers began their mission in 1977, scientists thought the boundary was somewhere just on the other side of Jupiter, some 365 million miles from Earth, but they actually had no idea how massive the Sun's bubble was. One of the most shocking discoveries Voyager 1 made in interstellar space is measuring the density of the interstellar medium. According to the data collected by the spacecraft, the particles in this space were higher in density compared to the outer regions of the heliosphere. The instrument that took the measurement was the plasma wave science, which detected electron density through the vibrations of plasma waves. Scientists actually expected the moment Voyager 1 crossed into interstellar space to be like a bleep, but they would learn that the boundary was much thicker and more complex than they thought. However, what they learned and observed from Voyager 1 was confirmed 6 years later when Voyager 2 also crossed the boundary. The scientists in charge of the mission were initially confused by the magnetic field data sent back by Voyager 1. They were expecting something different, like a noticeable change where the magnetic field of the Sun encountered the magnetic field from space, but they were shocked when the spacecraft did not detect any changes in magnetic field direction. Voyager 1, however, has developed a problem that threatened to bring the decades-long mission to an end. This was not the first time the spacecraft had run into problems, but the mission controllers were fearful that this might be the curtain call. What is wrong with this darling of the world of astronomy? Simply put, Voyager 1 has developed a memory problem. Many of us forget things on a daily basis with no serious consequences to our well-being. However, when you are located billions of miles from the Earth, memory problems could be fatal. For Voyager 1, it could mean NASA has heard from it for the last time. The space agency has spent months troubleshooting the aging spacecraft after it started sending back gibberish information. It led to a pause in the scientific work that Voyager 1 supports as the maintenance team tried to track down the problem. They have examined the flight subsystem, the computer unit that instructs the telemetry modulation unit to transmit data back to the Earth. From early findings, the culprit might be a single chip, which is part of another component known as the FDS. This possible breakthrough was achieved after NASA engineers sent out an instruction that prompted Voyager 1 to transmit back a readout of its FDS memory. The team then discovered that about 3% of the FDS memory had been corrupted. This was preventing the computer from functioning properly. What complicates the issue is simply age. Most of the devices we use are not designed to last more than 50 years, and when they have to operate in the harsh environment of space, it is nothing short of a miracle that these machines are still functioning. You also have to consider that many of the people who built the spacecraft are no longer around, others among them have moved on to something else or retired. Something else complicating the diagnostic process is distance. Currently, Voyager 1 is more than 15 billion miles away from the Earth. If you send out a signal to Voyager 1, it takes 22.5 hours, almost a day, for the spacecraft to receive it. The same is true when the spacecraft responds with its own message. Because the engineers have to wait 22.5 hours to get the message, it is like carrying out a conversation where you can only speak a single word per day. Engineers call it troubleshooting in slow motion. This makes the work of looking for the issues more or less educated guesswork. They can't even say with certainty what the issue is. They have suggested the chip in question was hit by an energetic particle from space, or the chip simply wore out after more than 45 years in service. The most frustrating aspect of this latest Voyager 1 crisis is that, based on the data available, the spacecraft simply can't figure out how to send the correct message back to Earth. It is functioning as fine as it could, but its communication with the Earth is hampered. To get to the root of the problem, NASA had to rouse an engineer from retirement. Bob Rasmussen started his career right out of school 2 years before the Voyagers took off and had worked on and off the mission before calling it quits. However, the allure of fixing the problems of an old buddy brought back the engineer. He was involved in another communication issue the spacecraft had and decided to stay on to fix any future problems. Ras and his colleague had their job cut out for them as they needed to understand the spacecraft as much as possible. This meant they had the tedious job of going through the original design schematics, which by this time consisted of papers that had yellowed and were pinned to various walls on the premises. The engineers likened it to archaeological digging in their diagnosing procedure. They would send commands once a week to Voyager 1. They usually send the messages on Friday and hear back on Sunday. The progress was slow, causing even more frustration. However, they are not giving up, not even among the senior leadership level team. The breakthrough mentioned earlier came in March when they examined one of the responses from the spacecraft. In the place of the garbled message they had been getting, Voyager 1 sent back a string of numbers that looked familiar. That was the Rosetta Stone moment, and one of the engineers quickly learned to understand the jumbled language that Voyager 1 now communicates with. A part of the response that was familiar revealed it originated from the FDS memory. The next issue was whether they should resign to using the new corrupted way Voyager 1 was communicating or whether it was possible to fix the glitch and return Voyager 1 to its original state. In space exploration circles, few Voyagers come close to Voyager 1 and Voyager 2 in terms of legendary status. When they embarked on their deep space scientific journeys almost 5 decades ago, few people could imagine the next generation of space scientists would still be mining data from them. The twin mission sponsored by the National Aeronautics and Space Administration, NASA, was originally to explore the furthest planets and the outer limits where the Sun's influence stops. However, the Voyagers have over the years managed to push the boundaries of humanity's knowledge of deep space into territories never imagined possible. Well, let's move ahead to the launch period. John, I understand you made the decision to launch the first one and call it Voyager 2, which confused all of my brethren in the press as to why you would launch despite the naming convention. Voyager 2 took off first. It was launched from Cape Canaveral, Florida, on August 20, 1977. The launching vehicle was a Titan Centaur rocket. Voyager 1 took off on its own spectacular journey about 2 weeks later, on September 5, 1977. Voyager 1, however, was able to reach its planetary targets faster because it launched on a faster, shorter